we are now tasked with a pretty cool problem, which is to write two equivalent ratios to the ratio of 14 to 8. That could be 14 llamas to every 8 billy goats on a farm. It could be 14 chocolate ice creams ordered to every 8 cookie and cream ice cream ordered. Who knows? But we want to be able to write equivalent ratios. Now, equivalent ratios are very much like writing equivalent fractions. In fact, you can even make it into that kind of problem. So to write an equivalent ratio, you multiply or divide each side of a ratio, or the numerator and denominator of a ratio, by the same number. So I'm going to do this in two ways. I'm going to write this as 14 to 8 with colon notation and with a fraction. So in colon notation, let's say that I have 14 to 8, and I want to write that as an equivalent ratio. Well, I could divide both 14 and 8 by 2. So dividing 14 by 2 gives us 7, and dividing 8 by 2 gives us 4. So a 7 to 4 ratio is the same as a 14 to 8 ratio. Now, that's because 7 parts to 4 parts, when we double it back up, gives us 14 to 8 parts. That's one way to write that equivalent ratio. We could write another equivalent ratio. How about we multiply each of these numbers instead of dividing them by 2? We can multiply each one by 2. So I've got 14 to 8 was the original ratio. And now I'm going to divide. Well, I'm not going to divide. I'm going to multiply, as I said, each one by 2. So 2 times 14 is 28, and 2 times 8 is 16. Also an equivalent ratio. Now, you could have, and this is just a different technique that I figured I'd put in here to write equivalent ratios, you can also write everything as fractions. So let me show you what I mean. I could have written 14 to 8 as 14 to 8 as a fraction. And that might be a little more comfortable for some people, because now you can look at this as writing equivalent fractions. We could divide the numerator and denominator by the same number 2 to get 7/4, or 7 to 4. And what we can also do is we could have started with 14 over 8 and multiplied the numerator and denominator by 2, and that gives us 28 to 16. Which, if you take a look at our original answers over here, are the same exact ratios that we got, just in colon form. So, some people like to convert things into a fraction first. Others like to convert, well, nothing, and leave it as a ratio in colon form. It's up to you, but it's all very similar to finding equivalent fractions. If you take a look at this problem too quickly, you might think, write 9:15 in simplest form? Why would we be writing a time of day in simplest form? Remember, it's a ratio, so write 9 parts to 15 parts, or the ratio 9 to 15 in simplest form. I'm going to show you two ways of doing this. It is so very much like simplifying a fraction because a ratio can be written as a fraction. So we're going to reduce this by dividing both parts of the ratio by the GCF, the greatest common factor. What is the GCF of 9 and 15? Well, the GCF is equal to 3. That's the largest number that goes into both of them. So if we reduce both sides of the ratio by the same exact value, dividing by 3, we're going to get an equivalent ratio. So I'm going to divide 9 by 3 and we get 3. And I'll divide 15 by 3 and we get 5. So the ratio of 3 to 5 is equivalent to 9 to 15. Other people, myself included, like to write these ratios in their equivalent fraction form instead of colon notation. 9 to 15 is the same as 9 over 15. Then I'm going to divide by the greatest common factor, so that would be dividing both the numerator and denominator by 3. And when we do that, we get 9 divided by 3, which is equal to 3 over 15 divided by 3, which is 5, both of which are equivalent ratios. A quick video, but one that I thought was important because dealing with fractions, ratios, in simplest form makes them a little more, well, simple, right? Have fun with it.